So next we'll do some one-step synthesis problems where we predict the products of these addition reactions. So the first step is to analyze the reagents used to determine what groups will be added across a double bond, or if we're doing ozonolysis, whether we're going to break the double bond. Then we're going to determine the regioselectivity, for example, whether it's Markovnikov or anti-Markovnikov. Then we'll determine the stereospecificity, whether it's syn or anti, or whether we get, racemic mixture, whatever. And you can do this, in my opinion, best by making flashcards of these reactions and memorizing them. But if you learn the mechanisms, it'll help you better predict the products. So it's important to learn the mechanisms, but it's also important to do some memorization on the front end to really get a good understanding of these, because you really just need to, you've got so many reactions, it's best to make flashcards and do some memorization. Alright, let's see if we can predict the products of these reactions here. So our first one, we've got BH3 and THF. So what is that? That's hydroboration oxidation. So what are we adding and where are we adding it? We're adding H and OH across a double bond. This is going to be anti-Markovnikov. Okay. And remember that the H and OH are going to add syn to each other. So we can predict our product here. We're going to add OH to the less substituted side. H is going to go to the more substituted side. We didn't create a chiral center, so the stereochemistry doesn't matter. So for the next one, we're adding H2 and platinum. So we're adding H, and those are going to add syn to each other. So for this reaction, if the methyl group's coming out and the hydrogen's going back, the other hydrogen will also be going back. Plus we'll get the enantiomer of that molecule. So for the next one, this is our RCO3H and H3O+. So that's anti-dihydroxylation. So we're going to add OH and OH, and we're going to add those anti to each other. So for this molecule, all right, we've got 6 over the ring over here. All right, that's our starting material. So let's erase the double bond and draw. Let's say if this OH is on a wedge, and we'll put the methyl on a dash, then the other OH is going to be on a dash. Okay, plus the enantiomer. Alright, for the next one, we've got Osmium Tetroxide. So what is that? That's OH and OH, so dihydroxylation. And this is syn dihydroxylation, so we're going to have syn addition. So that means if the methyl is on a wedge, the OH will be on a dash, and the other OH will be on a dash as well, plus the enantiomer. Okay, so for the last one, we have this starting material, so let's go ahead and erase the double bond. Now we just have H3O+. So what is this? This is hydration. And we're going to add H and OH across the double bond. We're going to add that with Markovnikov regiochemistry. And we're going to get a racemic mixture. Okay, so if the OH is on a wedge, then the hydrogen doesn't matter. It doesn't matter about the hydrogen. We're going to get a racemic mixture. We created a chiral carbon here, so we can say plus En. Okay. So for the next one, we have HBr. So this is hydrohalogenation. So we're adding H and Br. We're going to add those in Markovnikov fashion. and we go through a carbocation, so we get a racemic mixture. So if we've got the bromine on a wedge, then the ethyl group will be on a dash, and the bromine goes to the more substituted side because this is Markovnikov addition. The H went over here, but we're not showing that because it isn't necessary. Alright, for the next one, we've got the RCO3H and H3O+, so that's anti-dihydroxylation. So if our one OH is on a dash, the other one's going to be on a wedge, plus EN. Alright, the next one is the BH3THF, so that's H and OH. Okay, and we add those anti-Markovnikov. Okay, and what also? We get the OH going to the less substituted side. So that's OH over here, and the H and OH actually add SN to each other. Okay, like that. So that would mean this ethyl group's on a wedge. Alright, so next we've got this species here. We're breaking the double bond, okay? So we're adding something. We're adding an oxygen, double bonded oxygen, where the double bond was on each side. So let's see if we can redraw those. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So a carbon chain with 5 carbons. The second one's got a ketone group. And the next one is 1, 2, 3, 4 carbons. And the second one has a ketone group. So go through and see if you can predict the products on some different reactions and practice with that. Make flashcards, and I'll see you in the next video.